Burnt lungs is our taste. Lights gone, days end, struggling to pay rent. Long nights, strange men. They say she's in the class 18, stuck in her daydream. Been this way since 18, but lately her face seems slowly sinking, wasting, crumbling like pastries. And they scream the worst things in life come free to us, cause we're just under the upper hand. I'll go mad for a couple grams, and she don't wanna go outside tonight. And in a pipe she flies to the motherland, or sells love to another man. It's too cold outside for angels to fly, angels to fly. Ripped gloves, raincoat, tried to swim to stay afloat. Dry house, wet clothes. Loose change, banknotes, weary-eyed, dry throat. Cool girl, no phone. They say she's in the class 18, stuck in her daydream. Been this way since 18, but lately her face seems slowly sinking, wasting, crumbling like pastries. They scream the worst things in life come free to us, cause we're just under the upper hand. I'll go mad for a couple grams, but she don't wanna go outside tonight. And in a pipe she flies to the motherland, sells love to another man. It's too cold outside for angels to fly. An angel will die, covered in white. Closed eye, hope for a better life. This time we'll fade out tonight, straight down the line. They say she's in the class 18, stuck in her daydream. Been this way since 18, but lately her face seems slowly sinking, wasting, crumbling like pastries. They scream the worst things in life come free to us, and we're all under the upper hand. Go mad for a couple grams. We don't wanna go outside tonight. In the pipe, fly to the motherland, or sell love to another man. It's too cold outside for angels to fly. Angels to fly. Fly, fly. For angels to fly, to fly, to fly. Angels to fly. One, two, three, four. Hands in your body, I'm grabbing your ass, enjoying the moment, cause life moved too fast. I'm looking forward, ignoring the past. These are the times that will laugh looking back. I'm getting lucky like coins in a well. Goodbye to my haters, I'm wishing you well. This is my man, if you couldn't tell. This is our life and we living it well. Late nights in this city causing hell. Burn this bitch into the ground, oh well. For all we got tonight, let's do this right. Let's do this right. Let's go to. This shit be like Friday nights. This shit feelings. It's energy, precise in the memory. I look the bands, he been working all summer. Ex didn't know what he had with a bummer. Insecure people turn to insecure lovers. But my drink is almost out and I'm about to pour another. Just let it out. The night has just begun, we on alert. Oh now, if I get too fucked up, promise you'll hold me down. Yeah, it's that shit you can't deny. It's that shit you feel inside. It's our life, our time, we living well. Late nights in the city causing hell. Burn this bitch into the ground, oh well. If all we got tonight, let's do this right. Let's do this right. Let's go to paradise. This shit be like Friday nights. This shit made me feel alive. Feel like we in paradise. Paradise. Don't know if it's a dream or what. But I swear I've never loved you more. With you right here, I come alive. I'm holding and we can fly. This shit feel like heaven. We open with the vultures, kissing the cannibals. Should I get lonely when I'm only human in the heat of the animals? The brown salt stinging on my tongue. I wanna waver, I wanna wait its turn. It will burn your love into the ground. The lips of another. Did you get lonely? Should I get lonely sometimes? All my friends are wasted. And I hate this love. And I drink too much. Another Friday night, I'm wasted. My eyes are black and red. I'm crawling back to you, babe. Pharmacy addict hit a Wall Street traffic, took the car. We reinvent the wheel just to fall asleep addicts. Crash on the floor and catch the ZZZ. Pop in the polar opposite the NCG. Hip hop in the propaganda say they name brand. But I just seen how the did my main man. The nights you won't remember are the nights you won't remember. I'll be gone till November on my city car. Dreams of me vacations, nigga lines are for real, nigga dying is for real. Niggas dying on the field, nigga bodies up for chill. Ran at the stand, I'm leaving 10 if you're up right now. Hear what I'm saying? All my friends are wasted. And I hate this club. And I drink too much. Another Friday night, I'm wasted. My eyes are black and red. I'm crawling back to you, baby. Should I get lonely some nights when the edge on my shoulder slump ahead? I'm stuck here with the vultures hissing and circling. You didn't call me. Call me. I'm crawling back to you. My friends are wasted. And I hate this club. And I drink too much. On a Friday night, I'm wasted. My eyes are back again. I'm crawling back to you, babe. All my friends are wasted. And I hate this club. And I drink too much. On a Friday night, I'm Yo, ayo, tonight is the night that I'ma get twisted. Mix Moscato and vodka, I'ma mix it. Roll that spaceship, we about to get lifted. Live in the present and gift is for the gifted. This what you came, this what you came for. You get what you buy, this what you pay for. So make sure the stars is what you aim for. Make mistakes though. I never worry, life is a journey. I just wanna enjoy my life. But it's a hurry, it's pretty early. It's okay, we'll take our time. The night is still young. The night is still young. The night is still young. And so are we. The night is still young. The night is still young. Hey yo, drinks on you or the drinks is on me. We ain't going nowhere like tanks is on E. We still getting money for pay. Okay, hello, good morning everyone. Can you guys hear me loud and clear?
Yes po, sir.
Okay, ayun. Well, it's a brand new week. I hope everyone's doing well. So before anything else, let's pray. So I will begin in the prayer para mabilis kasi ay, nako, pag kayo ang ganon, pag kayo pa nag-lead, maubusan tayo ng oras. Okay, let's pray in the name of the Father, the Son, and the Holy Spirit. Amen. Our Father who art in heaven, hallowed be thy name. Thy kingdom come, thy will be done on earth as it is in heaven. Give us this day our daily bread and forgive us our trespasses as we forgive those who trespass against us. And lead us not into temptation, but deliver us from evil. Amen. In the name of the Father, the Son, and the Holy Spirit. Amen. Once again, good morning, everyone. Yeah. Wait lang, masakit yung lalamunan ko. So I believe everyone's admitted already and purging happened already. So let me just check your attendance for today. Let's start with the girls first. Say present as fast as you can. Okay? Para mabilis tayo. This is code 887. Okay, 887 tayo. So let's start with Bernal, Calvan, Capasio.
Present,
Capasio, ano
sir.
sa iyo?
Present po.
Okay. Sige. Bilisan natin guys ha. Wala si Bernal, no? Bernal. Okay. I-chat nyo na lang guys kung sira yung inyong mga ganun. Mga microphone. Geeking.
Present, sir.
Ignacio. Lagwa.
Present, sir.
Layugan.
Present po, sir.
Lorenzo. Okay. Peralta.
Present, sir.
Bakit daw? Bakit hindi makapasok si Lorenzo? Wala naman akong ganon, notif.
Sir,
Wala akong notif.
Bernal po.
Oo, yun. Wala kang notif. Bernal present.
Yes po, sir.
Okay. Next, Pingad.
Present, sir.
Sabado.
Present, sir.
Palatad.
Present po, sir.
Okay, and then si Vice President. Okay, let's proceed to the boys na. Agustin.
Present, sir.
Alameda.
Present, sir.
Artikulo.
Present, sir.
Bautista and Binayug.
Present, sir.
Present, sir.
Okay. Botavara.
Present, sir.
Kabatingan.
Present po, sir.
Next, Karodan. Karonan.
Present, sir.
Katindoy.
Present, sir.
Kureg and Domingo.
Present, sir.
Okay. Duruin and Lim.
Present, sir.
Okay. About si Lim, nandito ba siya? Parang kanina ko siya. Ayun. And then, Manuel and Matias. Okay, sige. Si Molina, hindi daw makakapasok kasi may shooting daw sila. Sige. Okay. Panganiban.
Present po, sir.
Kizagan. Uliden. Okay, next is Ramirez.
Present, sir.
Reyes.
Present, sir.
Rivera.
Present, sir.
Salvador Nov. How about si Sumarita?
Present, sir.
And Vinasway.
Present po, sir.
Okay, sige. Would you mind opening your camera for a while para makapag-document tayo?
Sir, ako sir, present.
Sino ka? Si Frida, ang late na pumasok. God. Okay, ayan. We're done. Ayan. Guys, who among you have the capability or has the capability to word or gano'n. Kasi it works in here to record yung session. Kasi hindi pala tayo nagre-record. Oh my God, mananagot ako nito. Okay. 2 session na tayo and ayun nga, hindi tayo nag-record. Sino ang may capability to record our discussion? Yung computer nila merong recording kineme, ganun. Pwede ba yung ganun? Kasi wala akong ganun. Hindi ko alam yan. Hindi naman ako teching. Hindi teching. Wala sa inyo, guys. Ito lang naman siya. Like, ganun.
Sir, ako po, sir.
Anong name mo? Sino ka?
Panganiban, sir.
So, guys. Panganiban. Sige, Don, ikaw na lang din mag-record. Okay lang ba?
Sige, sir.
Oo. I-record mo na lang. Now na. You can start now recording. Okay. So, wala pa akong na-receive, guys, na gano'n na ang tawag dito. Notice kung kailan ang maybe siguro after na ng before or after na ng foundation day, hindi ko alam. Okay. So, anyway, 8, 12, 16. We will be having na lang your quiz next week. Okay, next week na lang siya. Okay, maybe Thursday. Okay, kung may pasok man tayo. May pasok ba tayo that time? Ayun guys, kailan ang foundation day ninyo?
Sir, 9 to 12. 9 to 12 po.
9 to 12. May pasok ba that time or wala?
Wala po, sir.
So, Wednesday, Thursday, and Friday. Hanggang Saturday. Diyos ko, ano nangyari? Tapos wala na naman pasok ng Friday. Alam mo, wala na kaming na-discuss dun sa kabilang set. Okay, anyway, so we won't be having the quiz tomorrow. Is it okay if I just give you the quiz na lang on Sunday and then you can do that for the entire week? It will just be through Google Form lang naman. Okay, it will just be through Google Form. Kasi hindi ako makakapagbigay bukas kasi hindi ko siya na i-upload or na i-draft sa Google Form kasi nagra-rush din kami guys kasi meron kami requirements. Okay, meron akong reporting on Friday. Samantala kayo wala kayong pasok. Okay, so I'll just give you the link to the Google Form and then you can answer that until maybe sige. Kailan ang prelim exam? Do you have any idea guys kung kailan ang prelim exam?
Sir, yung tentative date 17 to 19 daw ata.
17 to 19? Tentative pa lang yun? Yes po. Sino naman to? Excuse na naman. Sino na naman ito? Sana hindi ka nila pumasok. You could just have chat me na lang. Oh, go na. Kaya nila pamitan, no? Oh, go na. Lahat ng may event, you can evaporate. Okay? You just chat me in Telegram if hindi kayo makakapasok kung meron kayong event. Okay? So, ayun lang naman. Ayun guys. So, I'll give you the quiz maybe on Sunday and then you have the entire week until before the prelim exam. Okay, until before the prelim exam, a day before the prelim exam to answer that. Anyway, we will just be having one quiz naman and once it works, the quiz will be considered as your set work as well. And then yung second quiz and last quiz ninyo for prelim will be the research critic and that will be submitted as well before the prelim exam. Okay, klaro tayo? So kung tentative is 17, 18, and 19, you should submit all of your requirements by 16. Okay, Wednesday, that is 16. Okay, are we clear?
Yes, sir.
Okay, so let's proceed to the lesson then. Once again, our lesson for today is somewhat blah blah in general information. Okay, kasi by midterms din lang natin siya i-apply. So, huwag kayo mag-expect na yung inyong tawag dito, prelim exam and quiz will have like super complicated computations, but rather it will just be code-based. Okay, code-based lang siya. So, open naman yung codes natin sa exam. Open yung codes natin during the exam. Okay, you can just access that one. I already uploaded the references sa ating LMS. Okay, may separate folder tayo doon. Sobrang dami nun. Okay, doon yung dalawang book and then dalawang code. Okay, so yung gagamitin natin is yung ASCE na code muna. Okay, for the loads. Okay, so we will be talking about loads the entire semester ngayong prelim lang. Okay. Okay. So, ayun. Dalawa ng ganun. Okay. So, once again, feel free to sleep if you want to. Okay, hindi ko na pipilitin, but I will be calling some people to read kasi medyo masakit na yung lalamunan ko. Okay. So, chichikahan lang tayo the entire day. Okay. So, how was your research critic? May nakatapos na ba? By the way, the file name of your research critic, okay, should be your name. Okay, yung last name niyo and then yung first name. Okay, that's the file name. And then it should be in Word file. Okay, Word file tayo. Okay, so let me just share to you the screen now. Ayan. So today we will be talking about wind loads and the general requirements. Actually, on the ASCE loading codes, okay, for in the references that we have, sobrang haba ng wind loads, pero hindi natin siya i-cover. Okay, lahat. We will just be talking about the general requirements. So it is up to you later on to check, okay, or to study on your own what wind loads, what specific provisions for the wind loads. In here lang, in-include ko lang dito general requirements lang. Anyway, the section is actually separated. Okay, sobrang dami kasing sections nun. So feel free to download na lang yung PDF file, guys. Nasa references siya na folder sa ating LMS. Okay? So meron tayong submission links, yung requirements, and then yung separate folder for the references. Okay, so let's start. I will not be going in depth with the definitions. Okay, the definitions. I will not, kasi sobrang daming definition dito. So, this is actually 6 slides. Okay, so sobrang dami ng chapters ng wind loads. Okay, and next week, I will be uploading the seismic loading. Yun lang. Okay, so inihuli ko na yung seismic loading kasi yun mas matindi siya. So sobrang complicated nito. And just to set expectations, guys, I'm not knowledgeable, okay, in terms of the wind loads, okay. In terms of the wind loads, what I will be doing is that tomorrow I will send you a video explaining wind loads. For me, kung ano lang yung naiintindihan ko ngayon, yun lang yung ipaparating ko sa inyo. Okay? So please bear with me. At least, ayun lang. I just want to be transparent. Okay? Hindi ko alam kung ba't nila binigay sa akin ng RC. Kung naman ito for... Dapat si Sir Frase, mga ganyan nagtuturo na ito. Okay. Anyway, sige. Let's start with wind loads. So what are wind loads ba? Basically, we are considering wind loads in the structural design. Okay? This is to aid the building in resisting hurricanes, mga ganyan, and definitely yung malalakas na hangin. Okay, so that's why we consider the wind as a loading. So in terms of the procedure, okay, buildings and other structures, including the main wind force resisting system, or the MWFRS, and all components and cladding, CNC, therefore shall be designed and constructed to resist the wind loads determined in accordance with Chapter 26 through 31. So you could just imagine there are technically 5 chapters in the ASCE specification that is talking about wind loads. Ganun siya katindi, guys. Okay, so it depends din kung ano yung location ninyo. Okay, so in here, we won't be talking about the Philippine setting, but rather we will be talking about anong tawag dito, the US setting. Okay, the US setting. So later on, though we are using the US setting, okay, the US setting, in your design later on, it's up to you kung anong gusto nyong gamitin. Okay? Pwede kayong mag-NSCP, guys, yung gusto ninyo. Actually, halos pareho lang naman kasi yung provisions ng ASCE sa NSCP. Okay? So, nagkaiba lang yung mga load factors and yung mga constants na ginamit, pati yung variables. Okay? Kasi magkaiba tayo ng wind loads sa ibang bansa. Pero if I were you, you just use na lang whatever is available in the stand. Okay, kasi pipick ka lang naman doon kung ano yung gusto mong gamitin. Kung ASC iba, hindi ko alam kung may NSTP doon. Pero maraming ganun doon, guys. Maraming programming codes in the STAAD. Okay, do you all have STAAD in your computer?
Yes, sir.
Okay, so later on, midterms, gagawin natin is we will be doing models. Okay, pero yun, hindi na ako magdi-discuss nun, guys, ha? Hindi ako magdi-discuss nun. Kasi walang STAAD tong computer ko. At saka yung computer ko na to, bulok na siya. Hindi siya pwedeng mag-run na ng mabigat na software. Okay, so ayun. So I will just be sending you a video tutorial na lang. Okay, for the STAAD. Okay? So next is permitted procedures. So the design and wind loads for buildings and other structures, including the MWFRS and CNC elements thereof, shall be determined using one of the procedures as specified in this section. Okay? So meron tayong outline. Okay? Mamaya, napapakita ko kung paano natin i-determine yung mga yung loads natin for the wind. Okay? So yung main wind force resisting system natin shall be determined using one of the following procedures. Okay, so we have this 4 different procedures. So the first one is the directional procedure. Okay, second one is the envelope procedure, and then directional procedure, and last one is wind tunnel procedure. Okay, for the directional procedure, okay, consider natin dito yung height ng building, okay, which is specified in chapter 27. Okay, and then it depends really on the height of these buildings as well as the characteristic of the building kung ano procedure yung gagawin din natin. Pero normally, ang ginagawang procedure dito is the directional procedure for buildings. Okay, and then yung envelope procedure naman, that is for low-rise buildings lang. So, meron tayong specific height, okay, na kumbaga if-follow. And then the last one is the wind tunnel procedure. Okay?
Sir?
Yes po.
Sir?
Di po naka-present yung PowerPoint, sir.
Ay, nawala. Oh my God. Wait lang. Okay, how about now? Meron na?
Meron na, sir.
Okay, so going back, we have these 4 different procedures in determining which method are we going to use for the MWFRS. Okay, so we have the directional envelope, then we have another directional, pero that's for building appurtenances, and then the wind tunnel procedure. So, as I was saying, it depends kung anong height ng building and yung characteristics ng building yung procedure na gagamitin mo. Okay, pero normally, kapag standard lang naman na high-rise building, we're actually doing the directional procedure, or we're just sticking to the directional procedure. Otherwise, okay, kung wala man dun sa first 3 yung conditions, okay, nung inyong structure, you have to deal with or to apply the wind tunnel procedure for all buildings. Anyway, these are just the general these items are just a general idea about the methods in determining the wind loads for MWFRS. Okay, so yun yung mga main wind force resisting system natin. Okay? So, components and cladding. Ano naman tong components and cladding na to? So, wind loads on CNC. Okay, take note, components and cladding is termed as CNC in the code. Okay? So, this will be designed using analytical procedure and the wind tunnel procedure. Okay? So, yung analytical procedure na yan, okay, will be discussed sa chapter 30, and yung wind tunnel procedure naman will be on the chapter 31. Okay? Okay, so I'm gonna be skipping the definitions kasi sobrang dami nito. Okay, so in your case later on, please feel free have time to read this tomorrow, maybe, okay, during our laboratory. Basahin nyo na lang siya. And whatever is hindi natin matapos today will be, hindi na siya magiging part ng prelim exam, but you have to read that. Although, yun nga, sabi ko din naman, more on
discussion lang naman tayo ng prelim because on the syllabus, we have to discuss yung mga wind loads, okay, mga ganyan, mga loadings, okay, before we go to the modeling, okay? So chapter 26, that's what we're going to discuss today, okay? That's the general requirement used to determine the basic parameters, okay, for determining wind loads on both the MWFRS and CNC. Okay, so these basic parameters are the basic wind speed, meron tayo nito, including sa NSCP, and then we have the wind directionality factor, KD, exposure, type, topographic factors, ground elevation, velocity pressure, gust effect factor, and closure classification, and then internal pressure coefficient. And then upon identifying the requirements, general requirements, okay, we now proceed to the analysis of, or to the methods, okay, for both the MWFRS and the CNC, okay? So, on chapter 26 on general requirements, then we have chapter 27, 28, 29. Those are now the procedures for the MWFRS, and your wind loads for the CNC is stipulated on chapter 30 and chapter 31. Okay, so etong sa baba na ito, chapter 27, 28, 29, 30, 31 na yan, hindi ko na siya sinama dito sa ating tawag dito, ating presentation. Okay, we're just gonna talk about the general requirements because if I were to include that, abutin tayo ng the entire semester discussing that one. How much more yung seismic analysis natin. Okay, so this is the outline of process for determining the wind loads. Okay, so take note, this graph will be a part of your prelim exam. Okay, so I gave you already a clue. Okay, so this graph will be part of your midterm exam. Okay, so skip na natin itong mga to. These are the definitions. Sobrang dami. I need to include it kasi it's necessary. Okay. So the general requirements for this. So we have the sign convention. Kapag yung inyong excuse me. Kapag yung inyong wind force is actually it tends to approach the surface. Okay, we consider that as positive pressure. Okay, if it tends to go away, okay, parang gano'n, parang lumalayo siya from the structure itself, you have to put a negative sign, okay, for the wind loading. Okay, so if it acts, okay, on the object, it's positive. Kumbaga parang compression and tension lang. Pero if it acts away from the object, it should be negative. Okay, so that's our sign convention. Then we have the critical load condition. Okay, so values of external internal pressures shall be combined algebraically to determine the most critical load. Okay, so in here we will just be taking the sum. Okay, kumbaga superimpose natin yung internal and external pressure kasi yung wind load natin hindi lang yan na-apply sa labas but also sa loob. Okay, so you just need to take the algebraic sum of the wind loads externally and internally, okay, to get the most critical load condition. Okay, then we have as well 26.4.3 wind pressures acting on opposite faces of each building in calculation of design wind loads for the MWFRS and for CNC for buildings. The algebraic sum of the pressures acting on the opposite faces of each building surface shall be taken into account. What if dun sa facade ng building and then sa rear part ng building, both forces are acting towards the structure? So of course, the summation of forces, horizontal, vertical, mga ganyan guys, you just need to apply that. And then, kumbaga, kunin mo yung magnitude ng resultant ng opposing pressure, wind pressure ninyo. Okay? Kasi hindi lahat ng building is acting towards lang or acting towards and away from the object yung forces. Nawala na naman ba yung presentation?
Yes, sir.
Alam, bakit nawawala? What is going on? Nawawala yung presentation ko. Hindi ko alam kung bakit. Okay. Can someone just share na lang the screen? You can just download yung PowerPoint file doon sa may LMS. Then kayo na lang mag-share para diretso tayo. Kasi nawawala yung... Hindi ko alam kung anong meron, guys, sa akin. Pero nawawala-wala yung presentation ko. Can someone just download now and then while I'm presenting later on, sino gusto mag-volunteer, guys? Mag-project ng screen nila. Nawawala-wala kasi yun sa akin. Ayan. Ayan, so paranormal, may paranormal something dito. Okay. So, ayun guys, going back, if we have two opposing forces, so summation of forces, horizontal or vertical, yun lang yung gagawin natin in order to get the magnitude of the resultant forces. Okay? So, yun yung general procedure. If you have designed a building that actually has two opposing wind pressures on it. Pero in many cases, wala namang ganung klaseng building. Pero wala namang ganung klase. Typically, walang ganung klase ng building na yung dalawang dalawang wind force is actually acting on the object. Okay, so those forces are opposing. Normally, ang nangyayari is one is actually acting towards the building and at the other side, it acts away from the building. Mga ganyan. Okay? So, yung direction kasi ng wind natin is actually, it goes in different directions, okay, in terms of the orientation of the structure. Pero, some of the faces of the building, kasi sabihin lang natin 4 faces yung building niyo, yung iba doon, hindi lahat ng wind pressure is actually acting towards it, okay? Some of the forces are acting out of the structure. Okay, so that's the idea behind the wind pressure. Okay, opposing faces and the critical load condition. Okay, then we have to identify as well the risk category of the building. Okay, this really depends on the hazard map. So, meron tayong hazard map sa ASCE code. Pero hindi ko na in-include lahat kasi sobrang dami ng hazard map doon. And yung hazard map doon is US-based. Okay? So, yung basic wind speed natin na V, okay, used in the determination of design wind loads on buildings and other structures shall be determined from figures 26.5-1 and 26.5-2 as follows, except as provided in sections 26.5.2 and 26.5.3, okay? So the identification of your basic wind speed, that's the V, okay, will be through figure 26.5-1 and -2, okay? So kung meron man, there are actually some specifications in 26.5.2 and 0.3 in terms of the basic wind speed. So wag kayong ma-confuse. Kung ano yung hindi na stipulate or hindi na state sa 26.5.2 and 0.3, okay, na basic wind speed, puntahan nyo yung figure 26.5-1 and -2, and that will be your basic wind speed. Okay. Now, we do have different types of risk categories in here. We have category 1, 2, 3, and 4. Okay. So for building category 1 buildings and structures, okay, gagamitin natin is 26.5-1A and 26.5-2A. Then we have category 2 naman, yung 26.5-1B and 2B yung gagamitin, and so on and so forth. So you have to check, okay, kung anong risk categorization siya, and yung basic wind speed niya will be identified through the respective figures stipulated in 26.5.1. Okay, and the wind shall be assumed to come from any horizontal direction. So take note, horizontal direction ng wind natin. So the basic wind speed shall be increased where records or experience indicate that the wind speeds are higher than those reflected in figures 26.5-1 and 26.5-2. Now, so yung ating wind speed, okay, stipulated in this particular figures and in section 26.5.2, hindi yun yung final na gagamitin natin. In the case of records, recent records, kasi di ba ang ating ASCE or ang ating NSCP, those are actually revised lang, maybe once every 5 years. So, ganyan yung trend. Pero once we discovered that a particular hurricane has this basic wind speed, kasi the climate change, mga ganyan. So, there's a lot of changes in the characteristics of natural phenomenon, okay? So, yung basic wind speed natin, whichever is higher, okay, in terms of the records, though hindi siya stipulated in our wind hazard map, yun yung gagamitin natin. For example, before Yolanda hit the country, our basic wind speed is like below 250, mga ganyan, 250 kilometers per hour, mga ganyan. Pero when we had Yolanda, mga ganyan na, I think like maybe 300 siya. I'm just not sure, guys, kung ano yung ito lang yung tatandaan ko based on my on my memory, pero yung memory ko hindi siya masyadong reliable, guys. Okay. So, ang natatandaan ko is lumagpas pa siya ng 300. Okay, lumagpas pa siya ng 300 kasi sobrang lakas ng hangin ng Yolanda. So, that's why nagkaroon tayo ng revision sa code and then parang tinaasan nila yung basic wind speed, mga ganyan, in terms of sa code niya. Okay, so there were revisions. Okay, so it really depends on the records. Pero in our case, okay, and since for educational purposes, we're just going to use yung figures 26.5-A, -1A, mga ganyan, hanggang dun sa 26.5-2. Okay, so whichever is higher in the records, that's the basic wind speed that you're going to use. Okay. Next, special wind regions. So we have mountain terrain, gorges, I don't know, and special wind regions shown in figure 26.5-1 shall be examined for unusual wind conditions. The authority having jurisdiction shall, if necessary, adjust the values given in 26.5-1 to account for higher local wind speeds. Such adjustment shall be based on meteorological information and an estimate of the basic wind speed obtained in accordance with the provisions of 26.5.3. So, in the case of terrain, may mga terrain, okay, or mountainous region, mga ganyan, hindi basta-basta yung pag-identify ng basic wind speed. Okay? So, hindi mo pwedeng gamitin yung figures 26.5-1 and 2-2 for mountainous terrains and other similar geography. Okay? Kasi iba, guys, yung basic wind speed kasi natin is assume horizontal. Pero in mountainous regions, of course, it's not always horizontal in nature kasi meron nga na-sloping nga siya, mga ganyan. So in here, the authority having jurisdiction should be the one to identify the basic wind speed, okay, for that particular region, okay? And it should be based on section 26.5.3. Okay, so they're going to estimate the basic wind speed. Okay, so yung authority having jurisdiction na yan, I think in the Philippines, that will be the national, the Association of Structural Engineers of the Philippines. Okay, so I think estimation ng ating basic wind speeds from regional climatic data. Okay, so the authority having jurisdiction will be soliciting resources from the Meteorological Society or the regional climatic tawag dito, organization such as Pag-asa, maybe. I think in our case, it's Pag-asa, to determine kung ano yung latest trend. Nawala na naman. Ayan. Oy, Miss Karen, thank you. Ayan, thank you for your screen. I think nawawala. Hindi ko alam, guys, kung bakit nawawala. Naglolo ko. Hindi naman ako gano'n. Nakakat-cut ba yung voice ko, guys?
Hindi naman.
Ayun. So, I think it's really the laptop. Alam mo, itatapon ko na talaga itong laptop nito. Pinagtsatsagaan ko lang talaga siya. Okay. Okay, kasi wala akong personal laptop, guys. Ayun. Nasira yung laptop ko, nabagsak ko. Ayan. So, ayan, going back. Okay, so this is now 26.5.3. This is ayan. Ayan guys, nag-leave ako saglit kasi my mic is not working bigla. Ayan. Okay. So I hope everyone can hear me now. So going back, so for the estimation of the basic wind speeds from regional climatic data, we will be gathering some references from Pag-asa, mga ganyan. It depends kung ano talaga yung governing body in terms of the weather, mga ganyan. Okay, or any agency na magbibigyan tayo ng climatic data. Okay, so in areas under outside hurricane-prone regions, kasi meron tayong mga areas under regions that are not really hit by earthquake. I don't know, something like in Mindanao, there are somewhere in Mindanao, I believe somewhere in Mindanao, hindi sila masyadong nababagyo dyan. Okay, for sure. It's just the northern archipelago and the middle archipelago that is actually prone to ano tawag ito, hurricanes. Okay? So yung regional climatic data shall only be used in lieu of the basic wind speeds given in figures 26.5-1 and 26.5-2. When, okay? First condition is approved extreme value statistical analysis procedures have been used in reducing the data. Okay? So, ito guys, yung statistical analysis procedure na ito, hindi tayong gumagawa niyan. Okay? Hindi tayong gumagawa niyan. We only make suggestions. Okay? We only make suggestions in terms of the basic wind speed na ibibigay ng agency, and then they will be the one to give the correlation or to give like the best value, okay, kung ano yung magandang gamitin for the design. Okay, second condition is that the length of record or sampling error, averaging time, anemometer height, data quality, and terrain exposure of the anemometer have been taken into account. Okay, so of course when you're trying to gather data in terms of wind pressure at that particular area, okay, we use a sampling method, okay? And we put a lot of anemometer tama ba? Anemometer in different places. Siyempre, hindi naman kasi flat terrain yung kino-consider natin. So we are actually considering sloping hills and mountains, mga ganyan. So there should be a lot of anemometer in that particular area, similar to rain gauges, guys, similar to rain gauges. When you're trying to get the average annual rainfall in a particular area, you have to use multiple rain gauges because just a single rain gauge won't tell you a very reliable data. So we're going to be using a lot of instruments in identifying the basic wind speed for the particular data, and then later on we're going to apply statistical analysis, okay, or the agency will apply statistical analysis to determine which basic wind speed will be the best fitted for the design of that particular building on that particular place. Okay, so yun. So there are a lot of anemometer. Okay, so the more the accurate, okay, the data it is. Okay, so in hurricane prone regions naman, okay,
So we have as well here, okay, stipulated in 26.5.3. Upon doing statistical analysis, for that terrain, okay, sabihin natin yung basic wind speed niya is below, okay, below the anong tawag dito? Below the stipulated values under figures 26.5-1 and 26.5-2, pwede lang yon. Okay? Pwede lang po yon. Okay? As long as the data is reliable. Okay? So, galing na kasi yun sa agency. Okay? So, we don't have any authority naman to question their computation and their ang tawag dito, analysis. Kasi sila yung experts sa field na yan. Okay? So, in hurricane-prone regions, wind speeds derived from simulation techniques shall only be used in lieu of the basic wind speeds given in figures 26.5-1 and -2. When approved, simulation and extreme value statistical analysis procedures are used. So, there are some agencies, guys, na nagkakandak ng wind testing, mga ganyan. So, they create these scale models and they actually subject that scale model into wind pressure. So yung mga wind engineer natin, mga ganyan, meron kasi mga ganun, guys. Sila yung actually nagkakandak ng mga simulation na ito. Okay? And this is actually for hurricane-prone regions lang. But take note that this simulation should be approved. Okay? And meron tayong statistical procedures on how to check if the data is actually usable in terms of the design. Okay, so I won't be discussing thoroughly kung ano ba yung extreme value statistical analysis na yan. Okay, kasi hindi ko din alam yan. Okay, ang alam ko lang dyan is that meron tayong tawag dito, kasi may kilala akong wind engineer. Meron silang software na ginagamit to identify yung extreme values for, or critical values for the wind pressure, okay, for the particular structure. So they are actually creating a lot of models and then they will subject it to wind load, and then there's this software, okay, simulation na nagbibigay sa kanila ng extreme na critical value, and then yung gagamitin nila for the wind load, okay? The use of regional wind speed data obtained from anemometers is not permitted to define the hurricane wind speed risk along the Gulf and Atlantic coast, the Caribbean, or Hawaii. Okay, this is in terms, guys, of US kasi. So that's why yung mga sinasabi dito is Gulf, Atlantic, mga ganyan. Okay? So when the basic wind speed is estimated from regional climatic data or simulation, the estimate shall correspond to the applicable mean recurrence interval, and the estimate shall be adjusted for equivalence to a 3-second gust wind speed at 33 feet 10 meter above the ground in exposure C. So meron tayong different types of exposures later on and will be discussed. Okay? Pero general lang siya. Okay, bigay ko lang idea with regards to the exposure type. Okay? So it depends really kung anong exposure meron yung building mo. Okay? So meron tayong conditions, okay, on how to determine the exposure type of the building. Okay? So next slide po tayo. So ito, guys, yung sinasabi ko ang regional climatic data. Okay? So yan po para siyang topographic map. Okay? Topographic map of have you seen, guys, anong tawag doon? Have you seen anong tawag doon? Have you seen a hydrograph? Hydrograph. Wala pa. You haven't seen that. So, itong lines na ito, guys, that just pertains to the average wind speed, okay, the basic wind speeds of that region, okay? So, if these lines are connected to each other, okay, similar to your topographic map, those places along that line, okay, along that curve, actually have the same wind speed. Okay, that's pareho lang siya sa inyong topographic map. So in the first figure, you see there, the first curve is 100 and then 45, mga ganyan. So yung 100 dyan, I think that's 100 miles per hour, and then yung isa naman is yung naka-parenthesis, I think that's 45 kilometers per hour o mga ganyan. So, ito guys, yung tinatawag nating ang tawag dito, yung wind map natin, wind hazard map natin. Okay? So, yung crosshatch dyan indicates the special wind region. Okay? So, hanapin dito yung place and then whatever is, how about if yung inyong place is in between two hatches? Okay? What if in between siya nung dalawang place or yung dalawang curve? Okay, for example, in the left side, we have 95 and then 100. What if in between siya? Well, ang ginagawa natin dyan to simplify the anong tawag dito? To simplify the computation, okay, we are not going to take the average, okay? We're not going to take the average, but we just consider which is higher in terms of the two cross hatches. Okay, so if you were to pick between 95 and 100, hindi pwedeng 95 plus 100 divided by 2, yun na yung magiging basic wind speed mo. Okay, hindi. Ang gawin mo, piliin mo na lang yung higher na curve. Okay? Higher na curve. Okay, next po tayo. Okay. So, meron tayong dito notes, okay, for the figure. Okay, so I won't be doing in-depth discussion of that. Next po. Okay, so meron din tayo nito. Okay, this is a continuation of the map. Okay, so meron tayong ibang locations in here. So as you can see, meron din tayo dun sa may left side, guys. Parang circular siya, or sabihin na lang natin pa-oval na graph ng wind. Okay, basic wind speed natin. So that's 105. And then meron din tayong point lang. Okay, kasi in this particular area, the wind speed is 107 miles. Okay, and then meron dun lang siya. Okay, parang isang point lang siya doon kasi doon lang naman may 107. Okay, so meron tayong pa-circular that indicates that the regions around this line are actually having a basic wind speed of about 105 miles per hour or 47 kilometers per hour. Okay, next po. Okay, so ito na yung wind directionality factor natin na KD. Okay, so itong depende guys kung ano, kasi general nasa general requirements lang tayo. So we will just be discussing yung kung ano ba yung mga factors na ito. Okay. So, meron na yung particular structure type and the wind directionality factor. Okay? So, meron tayong buildings. Okay? For buildings lang, ang directionality factor natin is 0.85. And then we also have components and cladding. So, MWFRS natin, 0.85. And components and cladding, CNC, will be 0.85 as well. Pero, if specified siya doon na meron circular domes, mga ganyan, arc, roof, and then chimneys, tanks, and similar structures, meron siyang corresponding directionality factor. Kumbaga, in the dead load, mga ganyan, in the dead loads and the live loads, meron tayong computation, okay, ng superimpose. Madali lang kasi yung computation ng superimpose, guys. Wala naman tayong problema doon. Sa wind speed kasi, or the wind loads, meron tayong different factors to consider. And this KD factor will be discussed further kapag gagamitin na natin siya in terms dun sa ating formula. Okay, kasi meron tayong formula dito na iba. Okay, so yung directionality factor KD natin will be 0.95. Okay, this is permitted for round or octagonal structures with non-axis symmetric structural systems. Okay. Ngayon, kung meron kayong octagonal or round na structure, okay, pero yung structure na to is non-symmetric in terms of the half of it is not symmetric to the other half, kumbaga hindi magkamukha yung half-half nila, you can use KD as 0.95. Okay? So, follow lang natin tong table na to later on in determining the KD factor for the wind direction. Okay? So, eto siya. Next po. Normally, guys, for the FRS, 0.85, okay, 0.85 I believe yung ginagamit. So, kapag sabing MWFRS na doon, hindi na kayo titingin sa iba, gawin niyo na lang yung KD factor ng ang tawag dito, ng MWFRS. Okay? So, yung wind directionality factor shall be determined from table 26.6-1 and shall be included in the wind loads calculated in chapters 27 to 30. So, the effect of wind directionality in determining wind loads in accordance with chapter 31 shall be based on a rational analysis of wind speeds conforming to the requirements of 26.5.3 and section 31.4.3. Okay, so a thorough discussion will be made on chapters 27 to 30. That is for the MWFRS. Okay, for the MWFRS. Okay, next po. Okay, so ito naman yung exposure natin na tinatawag. Okay, so ano ba itong exposure na to? So for each wind direction considered, the upwind exposure shall be based on ground surface roughness that is determined from national topography, vegetation, and constructed facilities. Of course, if your building is standalone and then wala naman siyang obstruction, okay, kumbaga nasa open space lang siya, yung inyong, ang tawag dito, yung inyong there's actually a great influence of exposure in the calculation of the wind loads. Okay, so kung wala kang masyadong obstruction, of course, yung wind mo will have a great impact on the structure. Pero kung medyo maraming puno, mga ganyan, and then maraming structure around the building that you are designing, of course, walang masyadong exposure. So that's why we consider exposure. If we do not consider exposure kasi, that will actually compromise your design in terms of economy. Okay, in terms of the economy. Okay, so wind directions and sectors naman for each selected wind direction at which the wind loads are to be determined, the exposure of the building of structure shall be determined for 2 upwind sectors extending 45 degrees on either side of the selected wind direction, and exposure in these 2 sectors shall be determined in accordance with sections 26.7.2 and 26.7.3. And the use of which would result in the highest wind loads shall be used to represent the winds from that direction. So meron tayong figure nito later on. I'm not sure kung maabutan pa natin, pero mas maintindihan niyo siya kung meron tayong figure. Okay. So next po. So meron din tayong surface roughness categories, guys. So yung exposure natin actually depends on the terrain as well. Okay, so meron tayong surface roughness B, C, and D. So ano ba itong mga roughness B, C, and D na to? Now, if your building is located somewhere in urban and suburban areas or like maybe rainforest, mga ganyan, with numerous closely spaced obstructions, gamit kayo ng surface roughness B. Okay? Then for surface roughness C, meron tayong open terrain. Okay? And then may scattered obstruction siya. Yun yung ating i-consider na roughness. Okay? So, check nyo din yung height, guys, nung inyong obstruction. So, if less than 30 feet siya or 9.1 meters, gamit kayo ng surface roughness C. Okay? So, technically, yung ibang, yung ating surface roughness C, it depends on ang tawag dito, the topography of the area, okay, the geography as well. Okay, so check nyo na lang later on kung anong surface roughness kaya. So, surface roughness D naman, we have flat, unobstructed areas and water surfaces. Ngayon, itong surface roughness D na to, this is actually sometimes used in construction on the sea and mga oceanic part, mga ganyan. So, di ba meron tayong mga construction doon, especially when you're trying to when you're trying to build an oil extraction facility in the middle of the sea. So yun guys. So ang ginagamit nilang wind surface roughness doon is surface V. Okay? Especially, it's not flat. Okay? It's not flat. Sabihin natin the sea is not flat. Okay? But there are through the breakthrough of technology, if I don't know if you've been watching some documentaries about oil exploration, something like the Shell, okay, even if ano tawag dito, the sea is actually nag-wave siya or kaya nagpo-pulse yung sea, the structure maintains its structural stability and doesn't really move, okay, although hindi siya anchored, okay, hindi siya anchored. So may mga ganun tayo na structure, guys. So in here, you should use surface roughness D. Okay. Next po. Okay. Meron din tayong exposure categories. Exposure B. Okay, so may exposure B tayo. Oh my God, hindi ko siya na-highlight. Okay, I will just upload na lang later on yung highlight nito. Okay, so meron tayong exposure categories, guys. We have categories B and C. Okay. For exposure B, okay, for buildings or other structures with a mean roof height less than or equal to 30 feet, exposure B shall apply where the ground surface roughness as defined by the surface roughness B prevails in the upwind direction, okay, for a distance greater than 1,500 feet. For buildings or other structures with a mean roof height greater than 30 feet, exposure B shall be applied to apply where surface roughness B prevails in the upwind direction for a distance greater than 2,600 feet or 20 times the height of a building or structure, whichever is greater. Okay. So, it depends kung anong height ng building yung kina-consider natin. Okay. Yung upwind height na yan, that is actually the what we're considering as the height of or a particular height of the wind pressure, okay, that we are actually taking into account. Ngayon, yung mean roof height ninyo is 9.1, okay, is equal to 9.1 or 30 feet, okay, exposure B tayo, okay, if and only if yung surface roughness natin is B, and then yung upwind direction natin, okay, is greater than 1,500 feet. Okay? So, other than that, if meron naman tayong mean roof height na 9.1 meters and then exposure B din siya, pero yung upwind direction natin is greater than 2,600 feet, well, mag-exposure B pa rin tayo. Okay? So, if the mean height is actually greater than 30 feet, mag-exposure B pa rin kayo. So, kung exposure C naman, okay, gamit kayo ng exposure C if and only if hindi applicable yung exposure B and exposure D. Okay? So, yun yung condition dyan. So, edit ko na lang ito mga guys, i-upload ko na lang guys. Okay? So, meron din tayong, do we have exposure D next po? Okay. Ito naman yung exposure D natin. So, in the exposure D naman, if your surface roughness is D, okay, and yung upwind direction natin is greater than 5,000 feet, okay, or 20 times the building or structure height, whichever is greater, exposure D shall also apply, okay? So, check nyo lang guys, check nyo lang later on if your kung exposure D siya, you have to see if the surface roughness is under D and then yung upwind direction should be greater than 5,000 feet or 1,524 meters, okay? Or 20 times the building or structure height, okay? So, yun kasi guys, the higher the building is, the more it is subjected to wind loads. Okay, for example, the Burj Khalifa. You know that the Burj Khalifa has this parang kumbaga parang lengua na design. I don't know if you call it lengua, pero parang tatlong sangay siya, parang starfish na, pero tatlo yung sangay niya. Okay, that is to consider. And then habang tumataas ka guys sa Burj Khalifa, panipis naman siya na panipis. Okay, kasi hindi pwedeng yung Burj Khalifa is actually just one big block, kasi it cannot withstand the wind pressure at the top. So the wind will actually topple the building, okay, and will actually babagsak na yung building, guys. Okay, so there's a science between the design of the Burj Khalifa. Okay, so try to watch that later on. Okay, then exposure D din, apply din natin siya guys kung yung surface roughness natin is upwind, okay, is B or C. Okay, pero yung inyong site is within a distance of 600 feet, okay, or 20 times the building or structure height, whichever is greater, from an exposure D condition as defined in the previous sentence, okay? If your exposure is a B and C, okay, pero yung distance niya is 600 feet, okay, within the first statement under exposure D, well, you have to use exposure D. Kasi wala naman tayong, kumbaga, malapit lang yung site natin sa isang exposed na structure or exposed na area, okay, na merong this particular exposure, okay? So even if the area is exposure B and C, pero malapit lang siya sa exposure D, well, you have to use exposure D condition, okay? For a site located in transition zone between exposure categories, the category resulting in the largest wind force shall be used, okay? For example, your exposure is actually, or your site is actually located in an exposure between B and D. So, anong gagamitin mong exposure? For example, hindi siya pasok dun sa distance sa 600 feet or 183 meters in radius. Anong gagamitin mo? Exposure. Okay, in between lang siya na exposure B and D, guys. So, ang gamitin mong exposure is actually the prevalent one. Okay, so in this case, you have to use exposure D. Okay, so whichever gives you the largest wind force. Okay, so there's an exception in here. So an intermediate exposure between the preceding categories is permitted in a transition zone, provided that it is determined by rational analysis method defined in the recognized literature. Ngayon, pwede din tayo magkaroon ng iba pang types of exposure, okay, other than what is stipulated in the code. So if there are articles published about some exposures, although may exposure C, sabi kasi doon if exposure C actually applies if your building category is actually not stipulated as exposure B and D. So, other than that, pwede tayong magkaroon ng particular na exposure. Okay? So, pwede tayong mag-create ng ating sariling exposure. If some of those that were mentioned actually doesn't fall in any of the exposure types. Okay? It depends on the governing body talaga. Okay? Kung sino talaga yung gumagawa ng, kung sino talaga yung may expertise dyan. Okay? So sila yung nagpo-provide kung anong, baga makiki-coordinate lang yung engineer kung anong magandang exposure. Pwede kasi sabihin yung expert in the field na hindi nyo pwedeng gawin yung exposure na yan kasi that's just indefinite exposure in this particular area. So what we're going to do is we're gonna just research about it, ganon, and we're just gonna apply some kumbaga ang tawag doon, scientific method, mga ganyan, observe maybe or like simulate, okay, in order for them to identify the best type of exposure other than stipulated on the code. Okay, so next po tayo. Okay. So we have exposure requirements naman tayo. So for the exposure requirements, it depends on the procedure that we are going to use. Okay. So kanina, di ba, we actually we have this procedure kanina na sinabi. Okay, pero the procedures are actually kumbaga yung mga procedures are discussed in each tawag dito, in each chapter, okay, after this particular chapter, so 27 to 31, okay. So let's have a review. What was the four, or what were the four procedures for the main wind force resisting system stipulated earlier? Sige, tawag tayo ng isa. Tingnan natin kung natandaan pa nila. Okay. Okay. So kanina, meron tayong mga, ito guys, these are the first two procedures, okay, that stipulated earlier. Ano pa yung dalawa? Try natin si Calvan o Ruth Keely. Nandito ka ba? Okay lang guys, if you say na gano'n na, sir, nakalimutan ko. Okay lang yun. Okay? Wala ba siya? Wala siya. Okay. How about si Rivera John Philip?
Yung dalawa pa, sir? Dalawang procedure?
Because there are four for the MWFRS and there are two for the components and cladding. So yung apat na main wind force, apat na procedure for the main wind force system.
Wind tunnel procedure, sir, tapos directional procedure.
Okay. Di ba we have first one is the directional procedure and then we have the envelope procedure. The other two is the directional procedure for the building appurtenances and yung last is yung wind tunnel procedure. Okay? So yung wind tunnel procedure, gagamitin nyo yun if wala doon sa first three procedures yung applicable na method ng inyong building. Okay? So under the exposure requirements in section 26.7.4 of the code, so for the directional procedure, for each wind direction considered, wind loads for the design of the MWFRS of enclosed and partially enclosed buildings using the directional procedure of Chapter 27 shall be based on the exposures as defined in section 26.7.3. Okay, so we're gonna be yung diniscuss natin kanina na type of exposure, yun yung magiging basis ninyo for the directional procedure. For the envelope procedure naman, yung inyong MWFRS for all low-rise buildings designed using envelope procedure of Chapter 28 shall be based on the category resulting in the highest wind loads or any wind direction at the site. Okay? So, yung ating first, okay, in the directional procedure, we have a definite exposure requirement. So, yung exposure B, C, D na yan, then we just need to check the condition. Pero in the envelope procedure, okay, we need to apply the three and choose among the three which actually best gives us the critical wind loading. Okay? So, kung ano yung magbibigay sa na highest the wind loading, yun na yung gagamitin natin. Okay? For any wind direction. Okay? So, yung wind direction kasi natin, guys, especially if you are, there are four corners or four faces of the building. Siyempre, we have yung leeward face, mga ganyan. Then we have yung sa side na faces. You need to apply din doon kung ano yung inyong wind loading later on, and then you just have to check kung ano ba yung most critical or gives you the maximum value for the loading. Okay? Okay, next tayo. Next po. Guys, if you weren't able to finish this one, I'll just leave it to your reading assignment na lang. So basahin nyo na lang yung mga hindi pa natin matatapos. Okay? By tomorrow kasi, I'll be giving you some videos maybe. Okay. So kung makahanap ako ng video kasi naghahanap ako kagabi, wala akong nahanap. Okay. So I'll be giving you some videos. Okay. And maybe you can work on your research critic na. Okay. If you're done, you can upload it na din. Okay. Upload it ahead of time, much better. Okay. So for the directional procedure naman for building appurtenances, okay, so if this particular procedure is applied, okay, so yung ating exposure requirement, okay, specified to, okay, specified siya sa chapter 29, which I think hindi na natin siya maabutan, okay. Appropriate exposure for each wind direction lang yung i-consider natin. Okay, so if you think that it is based on the judgment of the engineer later on, if you think exposure B is actually exposure B is more appropriate in the context of your directional procedure for building appurtenances, then go for it. Okay, so it depends on your judgment. Okay, so if you think exposure D, kasi yung exposure D natin, actually, kumbaga siya yung nagbibigay ng highest type of exposure. Okay? So if you think, to make my design conservative, I'll just proceed with exposure D. Okay? So exposure D. Ngayon, ang gagawin ninyo, let's just use exposure D kasi mas magiging conservative yung design ko. It will withstand exposures B and C, okay, if I'm going to use exposure D. Well, you can do that, but you don't need to sacrifice economy, okay, just to make your design kumbaga strong, mga ganyan, okay. So it will actually compromise the economy, so mas mahal siyang i-design, especially if you can use exposure B and C naman as the more appropriate type of exposures. Okay. Now, for C and C naman, so the design wind pressures for C and C shall be based on exposure category, resulting in the highest wind loads for any wind direction at the site. So similar to the second type of exposure, okay, yung exposure natin, second type of exposure, gagamitin natin lahat ng types of exposure. Okay. Yung specified kanina dun sa second procedure, yung directional envelope procedure rather, for the envelope procedure, na kung ano man daw yung exposure na magbibigay sa atin ng highest value ng critical loading, yun na yung gagamitin. And that is just similar to your components and cladding. Okay, for this T and C, kung ano yung exposure na bibigay sa atin ng highest value, yun yung gagamitin natin. Okay? So, it will be to your research na lang kung ano itong components and cladding. What do we mean when we say components and cladding? Mga ganyan. Okay, so research na lang yun, guys, on your end. Okay, so next exposure tayo, or next slide, please. So we're actually considering topographic effects. Okay, what do we mean when we say topography? Anyone from the group, what do we mean when we say topography? You can chat na lang, guys. You can chat what do we mean when we say topography. I-chat nyo na lang kung anong ibig sabihin ng topography in your case. Natural feature of an area, sir. Okay. So yun, guys, no, the very basic definition of topography is the natural feature of the area. So how does the physical characteristics, mga ganyan, okay? So ano ba yung particular na vegetation na meron dyan? Ano ba? Marami ba siyang puno? Mga ganyan. So yun yung tinatawag nating topography. Okay. So in the determination of wind loading, nasa na ba yung slide ko? Wait lang. Okay. So we need to consider the topographic effects. Okay. So ano ba to? So, meron tayong wind speed up over hills, ridges, and escarpments. Mga ganyan. So, i-search yun lang kung anong definition ng escarpment na yan. Okay? So, kung meron kayong particular na building at this location, for example, kasi di ba kanina we actually talked about terrain, may mga terrain, may mga hillside, gano'n. So, yung wind speed effects natin at isolated hills, ridges, and escarpments constituting abrupt changes in general topography located in any exposure category shall be included in determination of the wind loads. Okay, when site conditions and locations of buildings and other structures meet all of the following conditions. Okay, so meron kasi guys yung mga patag lang siya and then suddenly at some distance hillside na agad, mga ganon. So those features or those characteristics should be included in the design of the wind load. Okay, so ano ba itong mga ito? Okay, so these are the following conditions that should be followed. The first one is the hill ridge or escarpment is isolated and unobstructed upwind by other similar topographic features or comparable height for 100 times the height of the topographic feature. Okay, so 100 times age or 2 miles, whichever is less. So the distance shall be measured horizontally from the point at which the height of the hill ridge or escarpment is determined. Okay, so meron tayong figure later on yan, guys. Papakita sa inyo yung figure sa next slide. So the hill ridge or escarpment, kasi if your tawag dito, if your structure is located on a hill or a ridge, okay, or somewhere behind the hill or a ridge, that is one of the topographic effects that we need to consider. Okay, kasi there are certain obstructions. Okay, there are certain obstructions. So meron yung iba guys, yung wind speed nila, if you're patag tapos hilly, mga ganyan. Patag and then you have mountain. Siyempre, the wind actually has no obstruction dun sa patag. Pero when it hits the face of the mountain or the hill, ibang usapan na yun. Okay? Especially if abrupt yung change in the topography of the area. Okay? So we have to consider that one. So the next condition is the hill ridge or escarpment protrudes above the height of upwind terrain features within a 2-mile radius in any quadrant by a factor of 2 or more. Okay. Third one is the buildings or other structures located in as shown in figure 26-8, 0.8-1 in the upper one half of a hill or ridge or near the crest of an escarpment. And next, fourth condition is if the ratio of your height with your ang tawag dito, yung LH kasi hindi ko siya ma-explain sa inyo, pero meron na yung figure para mas maintindihan niyo siya. That's the length of the hill na sinasabi. Okay, that's the length of the hill. Now, yung ratio nilang dalawa is actually 0.2. And then yung 5 is H is greater than or equal to 15 feet for exposure C, D, and 18 feet naman, or 18 meters rather for exposure B. So next tayo, andun yung diagram guys. Ito yon. Ayan yung sinasabi ko sa inyong escarpment, mga ganyan, and then yung hill. Okay, so if you noticed in the first figure, meron tayong tawag dito, V, okay? The V natin, that's the basic wind speed. Now, the V is continuously moving along the horizontal position in the flat surface. Pero when it approaches the hill, okay, and it collides with the hill, there is a sudden change in pressure, okay? So yung speed up dyan na diagram, yan yung diagram ng pressure ng wind natin with it actually hits the face of the mountain or the hill itself. When that's also similar to yung 2D na ridge or yung 3D na axis symmetrical na hill. Okay? So, kumbaga yung bottom is actually, yung bottom ng original natin na V doon sa ating flat surface is na-cut siya. Okay? Na-cut siya doon sa bottom na yan. Okay? That's why meron tayong pressure diagram, okay, on this figure. Okay. Anyway, in the STAAD naman, okay, in the STAAD na yan, ang gagawin nyo lang naman doon is mag-i-input lang kayo ng gagamitin ninyo mga variable. Mga ganyan. Okay? So you don't need to like do something like this later on. Okay? So hindi kayo gagawa ng ganyan, guys. Hindi kayo ang magko-compute niyan. Parang pinakita niya lang sa inyo yung rationale behind the topographic effect. Okay? So ito yung kanyang figure and diagram. Okay? So, pipili lang kayo dyan ng inyong K1, K2 na multiplier later on, and then yun yung i-input nyo sa inyong tawag dito, STAAD. So, this is actually good for exposure C. Okay? So, next po tayo. Okay, so wag na natin i-discuss yung mga yan kasi andyan naman na yung notation. Okay, so we have K1 factor account for the shape of the topographic feature and maximum speed of effect. K2, we have reduction in speed, mga ganyan. So those are standard equations and yung kanilang legends. Okay, next na tayo para mabilis tayo. Okay. Anyway, general info lang naman tayo in the prelim. Okay, so ito na yung topographic, next pa po. Doon sa topographic factor. Ayan. So this is now your topographic factor, okay? So upon identifying now your K1, K2, and K3, you have to compute for the topographic factor. So the wind speed effect, wind speed up effect shall be included in the calculation of design wind loads by using the factor KZT. Kasi guys, di ba, when, sabi ko nga kanina, when i-try nyo guys yung magbuga kayo ng hangin in a sloping surface. If you try to blow a gust of air in a sloping surface, mararamdaman nyo if you are on the top of that slope area na kapag binugaan nyo yun, parang yung taas niya, okay, yung taas ng hill na yan or that particular object, malakas yung wind pressure doon. So that's why we have to do or we have to calculate topographic factor. Okay? So in here, ito yung pag-calculate ninyo ng topographic factor. Okay? So yan yun. It actually tells you kung how much amplifying energy or kumbaga yan yung amplification factor natin for the initial wind speed. Okay? So yan guys. Okay, next tayo. Okay, ground elevation factor naman tayo, guys. So, yung ground elevation factor natin to adjust the air density, okay, that's the KE, shall be determined in accordance with table 26.9-1. Okay, so it is permitted to take KE equals 1 for all elevations. It really depends, guys. If the elevation in table 26.9-1 is not applicable to the elevation of your structure, well, you can just use KE na 1. Okay. Next, we have velocity pressure. Okay. So under the velocity pressure natin, siya, based on exposure category determined in 26.7.3, a velocity pressure coefficient KZ or KH is as applicable shall be determined from table 26.10-1. Okay? So magbe-base tayo ng KZ and KH natin from table 26.10-1. Pero if applicable lang yung pressure exposure coefficient. Okay, for site located in a transition zone between exposure categories that is near to a change in ground surface roughness, intermediate values of Kz or Kh between those shown in table 26.10-1 are permitted, provided that they are determined by rational analysis method. Okay, so or related literature. So it is up to the experts in the field kung ano magiging values ng Kz natin. Depends really. Okay, especially if your site is located in different or between two different exposure types. So magkakaroon tayo ng intermediate value for the Kz and Kh. Okay? Okay. Next tayo. This is now table 26.9-1, ground elevation factor. Okay? So you have to check, guys, kung ano yung ground elevation ninyo. Okay? Above sea level. And then, ang gagamitin yung KE factor will be ito, yung corresponding KE factor nila for the height, okay, the elevation of your building. So in here, if your building is located 305 meters above sea level, you're going to use KE as 0.96. Okay? And then meron din tayo mga notes dyan, guys. Okay, may mga notes tayo dyan. Okay, so yung conservative approximation natin is 1. Okay, so if you don't want to compute anymore and don't want to assume values for the intermediate KZ and KH na yan, okay, you shall just use KE as 1. Okay, permitted naman siya in all cases. Okay. So the factor KE shall be determined from the above table using interpolation or from the following formula for all elevations. But if hindi naman siya stipulated dyan, for example, in between 1,000 and 2,000 feet siya. Okay? Well, alam niyo naman siguro mag-interpolate, no? So mag-interpolate lang kayo, upper minus lower should be equal to KE upper minus lower upper, mga ganyan, divided by. So you just get the ratio and proportion, then you just perform interpolation. Okay? Mga ganun. Okay. So tandaan nyo na lang na lahat ng KE is permitted to be taken as 1. Okay. So next tayo, 26.10-1. Okay. So ito yung mga pressure exposure coefficients natin. So, height above ground level naman ito. Okay, so yung KE natin, that's above sea level. Ito naman above ground level lang. Okay, and these are the respective values of the exposures. Okay, are the respective values of KH and KC in terms of the exposure. Okay, it depends on the height. Okay, so if your building is 30.5 meters above ground level, okay, so that's the height of the building, guys, ha? So yung under exposure B, that would be 0.96 if the height is 27.4. Okay, so follow lang natin yung table. Most of the values here naman are actually in terms of the table. Okay, then we have next po. Next is meron din tayong tinatawag na formula, or meron tayong kino-consider na formula if hindi naman pasok doon sa ating tawag dito, sa ating table, yung the height of the building. Pero rarely nakakapasok naman yung height ng building doon sa ating exposure type. Okay? So, for example, if the height of the building is actually, sabihin natin 152.4 meters. Okay, so high-rise siya. Pero ang actual height niya is 152 lang. Okay, 152 lang. Well, you can just use 152.4. Okay, pero basta close siya doon sa values stipulated on the table. Pero if not, okay, if it is actually lower, okay, kung meron pa siyang, kung yung KC is actually lower than 15 feet, mga ganyan, gamitin niyo itong formula na ito. Yung KC equals 2.01 ng Z all over ZG raised to 2 all over alpha. Mga ganyan. So yung alpha and ZG are tabulated in 26.11-1. Okay? Okay, next po tayo, velocity pressure. Ayan, ito naman for the velocity pressure, okay? So, kanina basic wind speed yun, that's V. Ngayon naman velocity pressure tayo. So, yung velocity pressure natin is designated as QZ. Okay, so ano ba itong QZ na to? Ano tong QZ na to? Okay, in every, if you can still remember your hydraulics, okay, in every, or like geotech, sabihin lang natin, Q equals area times velocity. Okay, yung mga ganyan. Yung inyong dito, yung inyong velocity, it actually produces as well a pressure. Okay, if you still remember yung velocity head, mga ganyan. Velocity head, tapos elevation, mga ganyan, and then pressure head, mga ganon. Yun guys, yung tinatawag, that's just similar to the velocity pressure QC. Okay, so how do we evaluate the velocity pressure QZ? Okay, so you need to identify first the height. Okay, the height of the building above the ground. Okay, ito yung gagamitin natin formula. So yung second formula yung gagamitin nyo ha, kasi that's in terms of SI unit. Okay, so yung first formula will be in terms of miles per hour. So yung QZ ninyo will be 0.613 multiplied by KZ, KZT, KD, KE, and V squared. So alam na natin yung V kanina, that's the basic wind speed. Yung KE naman natin, that's the pressure, velocity pressure, no, it's actually the ground elevation factor. How about yung KH and KZ? That is our velocity pressure exposure coefficients. Okay, yun yung ating KZ and KH. Okay, so you need to use this kasi later on, upon the analysis, okay, procedural analysis kanina, okay, using the 4 procedures, gagamitin natin yung value ng QC. Pero hindi na natin siya ipapakita dito guys kasi abutin tayo ng entire SEM mag-discuss ng tawag dito ng procedural, okay, procedural methods. Yung methods rather, for the MWFRS. Hindi yung 4 na procedure kanina. Okay? Next po tayo. So sabi dito, the velocity pressure at mean roof height is computed as QH equals QZ evaluated from equation 26.10-1. Okay? So yun yung kanina. Okay? Yun yung kaninang equation na binigay sa inyo. Using KZ at mean roof height H, the basic wind speed V used in determination of design wind loads on rooftop structures, rooftop equipment, and other building appurtenances shall consider risk category equal to the greater of the following. Okay? So, you have to check as well yung risk category natin. Diba kanina meron tayong risk category 1, 2, 3, 4. So, yung first na risk category natin for the building on which the equipment or appurtenances or risk category for any facility to which the equipment or appurtenance provides a necessary service. Okay? So, yung ating basic wind speed ng V, okay? Mag-base tayo doon sa ating risk category kanina. Okay? Although may already have method on how to determine the V. Diba? To determine the V, we have to check the wind map. Okay, that's the velocity, the basic wind speed is actually based from the wind map. Okay, kanina na pinakita. Ngayon, if you think that the basic wind speed actually is insufficient enough to be considered into the design, well, of course, you can actually ask yung inyong regional climatic agency, okay, which will provide you the regional climatic data later on. Okay. And you have to correlate this basic wind speed to the risk category. Okay, is it applicable for risk category 9, risk category 2, mga ganyan? So which will really provide you with the best design? Okay, so you have to consider yung risk categorization. Okay, pero in actual practice naman kasi, yung kung ano naman kasi yung basic wind speed, yun na. Okay, yun na yung ginagamit natin. Hindi na talaga tayo nag-check ng risk category. Kasi seldom na nangyayari yung hindi nagtutugma yung risk category niya sa wind speed. Okay, seldom yun na nangyayari, guys. So later on, kung ano na yung ibibigay ko na, maybe kung ano yung i-assume nyo na basic wind speed for that particular location, you can just use that. Okay, you can just use that. Wag na kayo mag-reference dun sa risk category para hindi na tayo masyadong mahirapan. Okay? Okay, next po tayo, 26.11. Okay. So we do have gust effects. Okay. So meron tayong tinatawag na gust effect factor and frequency determination. So the gust effect factor of a rigid building or other structure is permitted to be taken as 0.85. Okay. So yung gust effect factor ninyo, automatic na 0.85 na siya. Okay. Huwag na natin pahirapan yung mga sarili natin. Now to determine whether a building or structure is rigid or flexible, okay, as defined in section 26.2, fundamental natural frequency N1 shall be established using the structural properties and deformational characteristic of the resisting elements in a properly substantiated analysis. Okay, low-rise buildings as defined in section 26.2. Okay, so yung inyong tawag dito, yung inyong kasi sa 26.11.2 na yan, parang sinasabi na yun dyan is how do you determine if the building is actually rigid or flexible. Okay, so titingin ka dun sa natural frequency. Okay, so natural frequency ng building. Okay, if the natural frequency is actually stipulated in section 26.2. Okay, 26.2. I don't know if napasadaan natin siya kanina kasi nasa 26.11 na tayo. Pero mag-base tayo doon sa section 26.2, okay, na code, okay, to determine whether the building is actually rigid or flexible. But if I were you, para kumbaga to simplify the design, if I were you, you just put there kasi mas pansya. If you're going to, you just put there flexible. Okay, flexible siya. Okay, kasi kapag rigid kasi na sinabi, walang deformation. Pero pag flexible, meron siyang deformation. So which one is more conservative? You can just say that it is a flexible structure kasi RC members naman are not quite flexible. Okay, pero there are actually deformations, okay, sustained in RC structures. So later on, you can just put it here, flexible yung building. And then you can just check section 26.2 kung anong frequency yung gagamitin. Okay? Next po tayo. Ayan. So we have limitations for approximate natural frequency. Okay, kung mag-approximate tayo ng natural frequency, of course, we can do that, pero we have to set limitations. Okay, so as an alternative to performing an analysis to determine N1, the approximate building natural frequency NA shall be permitted to be calculated in accordance 26.11.3 for structural steel, concrete, or masonry buildings meeting the following requirements. Okay, so if your building has a height of 300 feet or 91 meters, and the building height is less than 4 times its effective length, take note, and yun. So these two conditions must be met. Okay, so height is 391 meters, and yung building height is less than 4 times its effective length. Okay, how do we determine the effective length? Okay, so next slide tayo, we'll give you the formula on how to determine the effective length in the direction under consideration. So first, you need to determine to which direction is the most critical. Okay, the most critical, and then after that, kunin natin yung effective na length, and this is just given by this equation in here, 26.11-1, and then